In this first session, we'll be going through Cosmos SDK. So Cosmos SDK is one of the major important tech stacks that we need to understand. It's built on Go, and it actually is an open source framework that allows us to build blockchains, application specific blockchains. Now I'll get into the detail of application specific blockchains, but first I'll try to establish a relationship between what blockchain development is and how it's different from a normal Web2 development. So in Web2 or in traditional websites and projects, web apps, basically, what we basically do is we have a server and then we have a front end and we try to connect those two through APIs. Now there could be CDNs, there could be proxies, and there could be a number of things in the process. But the end result is consuming HTTP requests to and from. In this blockchain ecosystem, what differs basically is instead of having code of your backend at one place, it's divided into multiple places that's decentralized stuff. And then through different people, it's called validator. I'll get into the detail in some time. So through different interactions from different people, you get into development of a blockchain ecosystem. I'll try to explain you with a different example. So most of you must know what Ethereum is. So it's a virtual machine where it's running, the chain is running, and people who want to develop their projects actually deploy their products on top of the virtual machine. And they have very little to no freedom with respect to what and how the Ethereum chain is running and how its upgrades are done. What Cosmos SDK offers differently is it allows you complete freedom over development instead of just deploying your products or applications on EVM or Ethereum virtual machine. So Cosmos SDK today that we'll be discussing has a lot of things that's embedded into it, and everything like Cosmos SDK is the base of everything that we'll be developing in this hackathon and in the upcoming sessions. So let's first get into what Cosmos SDK is. Comdex SDK is built on top of Cosmos SDK. So once we understand Cosmos SDK clearly, understanding Comdex SDK won't be an issue. So it was developed by Interchain Foundation, and it provides basically developers with some effort and support to develop their own blockchain. So Cosmos SDK is a blockchain on its own, and there are different layers to that particular blockchain. So Cosmos runs as a blockchain itself, and then it helps other blockchains run on top of it through deploying their own blockchains. So it's kind of a to and fro motion from Cosmos people. And when I am discussing about Cosmos SDK, there are different layers to it. So Cosmos SDK actually is an application level stuff. So what it's a state machine. So those of you who have learned or studied theory of automata, so you know what deterministic state machine is. You give an input and you get an output, and it is going to be deterministic across all different devices or across all different systems that you run it. One for a given input, the output has to be the same and it won't differ. So Cosmos SDK is kind of a state machine, and it's built on top of the Tendermint consensus algorithm. What Tendermint is, think of it like this. So in traditional projects, we have this front end and back end, and then there's database. So there are different individual items that actually make the whole product. So think of Cosmos SDK as a complete product with the help of Tendermint. So Tendermint is the consensus algorithm. What consensus algorithm is, for example, if I am a blockchain and some person is trying to do a transaction on me, I'll get into what transaction is in the next few slides. But think of transaction as an event that's occurring where change of currencies happen with very normal analogy. So someone is trying to do a transaction on me and try to add data on my particular blockchain. He's trying to do a currency exchange between two persons, and he's trying to add that data on my particular blockchain. So now, if anybody could do it freely without any type of check and balances, then a blockchain as a decentralized application would mean no sense. So there is a consensus algorithm which decides which particular transaction or which particular event is correct and which particular event is not in line with the whole protocol. So we'll be getting into Tendermint as a whole in the next session tomorrow. But today our most main focus is on how Cosmos SDK works. So in its depth, Tendermint has this consensus algorithm, which is the Byzantine fault tolerance algorithm. You must know what, like there is a old problem in which there are four generals and they are in a fight, and like they're at different places and they are actually in a war. Now what happens is if one particular general sends a message to another general, and what if the first general has made ties with the opponent or the enemy generals, So what if he sends message to generals on his own team with a wrong message? So he sends person to the next general and sends a wrong message that the enemy is not firing from this line. We could remove our forces from this particular side. What if other generals just agree to it and they would just lose the whole war? So in this general problem, Byzantine fault tolerance general problem, what happens is that one if one general says something, other three validates it first, and then only it gets added to their own war or whatever it's. So similar way, Tendermint, what it does is there are different consensus people who just check what one particular person is proposing to do, and if it's correct, rest agree with them. So there are a list of checks and balances that one has to follow. If it's not in line with what one is proposing, then it gets rejected. It's kind of a complex thing to understand in the first session itself, but as we move forward, we'll be able to understand it more. Tendermint is why I said something about Tendermint today is just to give you a brief overview of what it is, so that tomorrow when we discuss it, you guys have a better understanding of what and how Tendermint works. So you guys have heard about Android SDK, right? Android SDK allows you to develop your own Android apps. So just use this particular terminology where Cosmos SDK allows you to build your own blockchain. So just use this particular analogy, and this will help us understand a bit more. So one of the major benefits of Cosmos SDK is that it's very modular. We have different modules in Cosmos SDK. All modules are completely tested and they perform separate tasks, and like they have been doing that particular task as a coupled mechanism. So each module does its task in a fashion where it helps other modules, and that modules gets leveraged by other blockchains that they are using. So for example, Cosmos SDK has like 10 modules. Just take this number. Cosmos SDK has 10 modules. So for example, if I'm trying to build my own blockchain, I'll be taking all those 10 modules. I'll be using what the functionality those 10 modules are offering me. And on top of it, I'll be building more modules. And somehow my modules will again go and use those existing modules. So these modules are actually very important in order to build your own blockchain. We'll get into what all modules Cosmos SDK have and how it helps us to develop something. So what like the basic thing is, Cosmos offers a very base layer application to everyone who's trying to develop their own blockchain, and that could be leveraged to build your own product. And it's divided into different layers. We'll be seeing it in the next few slides. Security wise, Cosmos SDK is very, very secure. And like, of course, everything is only secure as until it's not secure anymore. So that's one thing. But yeah, Cosmos SDK is very secure mechanism wise. The consensus algorithm is very secure and it's very scalable. Like, let's suppose, for example, if I fork Cosmos SDK and then build my own products across on top of it, and then I have a very, very good user bandwidth, and that's increasing by day by day, and that's increasing exponentially. I won't be facing any issues interacting with any other people, or any people won't be having any issues in interacting with the blockchain because it's very scalable. There are ways to scale the whole blockchain, and it's a seamless process. Yes, of course, it won't be as seamless as I'm saying, but it's a seamless process. What interoperability means is that, for example, if person one is building their own blockchain and then person two is also building their own blockchain. So of course, in future, there could be some agendas where person one wants to interact with person two in some way. They want to cross offer their offers, cross offer blockchain users. So for that particular mechanism, Cosmos SDK has an inbuilt mechanism to interact between different blockchains. What this interaction means is that, think of INR as a token native to India. Think of USD, a native token to America. So think of this Cosmos SDK, your own blockchain, as India, and think of its native token INR as your native token. So it could be anything. Let's suppose it's XYZ token. So what IBC means is that, like on a very rough scale, what IBC means is that person one with token XYZ and person two with token ABC, for example, can easily transfer their token from place A to place B, that's blockchain A to blockchain B, very easily. Of course, there are some mechanisms to do that. You have to set up layers, you have to set up channels, but yeah, on a general level, Cosmos SDK allows you to do it, and it's very nice. But also one more thing, we are getting into the detail of developing a blockchain. Right now, the problem for this particular workshop is not for you to build a blockchain. The target here is to build application on top of the blockchain. But of course, in order to build a product, we need to understand the ecosystem. So the reason why the first few workshops are going to focus more on Cosmos SDK, Comdex SDK, Tendermint, and building the product on top of these is because you get a familiarity with how the system works, and then you could maybe move forward and try to build your own product. But you just need to understand some of this. You don't need to like know everything by heart, because there are a lot of docs will be helping you out. But just to have a basic overview of how these things work would be nice. Let's get to the next slide. So yeah, now I'll be discussing the components of Cosmos SDK. I'll be getting into the developer docs as well, and we'll be discussing some of the basic things there as well. So there are various components in Cosmos SDK. I'll be dividing those into three different. One is base app, one is multi-store, and one is module. Now let's try to understand each one of them separately. I'll also be getting into the code as well to explain you the places where you need to understand things by heart, because those would be the important points. So base app is a very foundational component of Cosmos SDK. So think of it like it's your gatekeeper. Everything or every logic that gets implemented is handled by the base app, and base app is very important, has a very important functionality of handling transactions. Now, I told you I'll be explaining transactions, but I'll be going back to a developer doc and showing you there how and what transactions are. So managing state is something that has to do with how transactions get added to the blockchain. So once I get there, I'll be explaining you again. So just as of now, understand the base app has some functionalities, and it allows you to handle the transactions. Like you don't handle it, the blockchain handles it, but it handles the transactions, it handles the state, and it executes the logic. So these three are very related. So what happens is when transaction comes to the blockchain, so for example, if person A is trying to send a UPI transaction to person B, the UPI is a transaction system in India as of now. So if person A is trying to send a transaction to person B, then UPI registers it somewhere, and that's why it subtract that particular amount from your bank account, right? So in a similar fashion, when someone is trying to send a transaction to the blockchain, two different persons through the blockchain, so what happens is there is a state change. So what state change here means is that something from your account would get deducted and someone's account will get credited with some amount, and then that particular state change will get stored in the blockchain forever until there is again new change, then it will get added. Now, this particular transaction across all different users of the blockchain gets added, and then it gets posted to the blockchain. So the block in the blockchain stands for holding these transactions and then adding it to the blockchain. So we'll be getting into the detail once I explain you multi-store and modules as well. So this was mostly about base app. So it's a very important, all the components of Cosmos SDK are important, but base app is very base layer and very important. Multi-store, think of it as like storing all the data of your blockchain. So I won't get into much detail of multi-store, but think of it like this. It's a library which has different sections, and each section is responsible for storing your data. I think that's the simplest explanation that I could give you about multi-store. So as a developer, you won't be dealing with this particular term multi-store, but what you'll be dealing with is KV store. So multi-store has a subunit called KV store, where you store data as a key value pair. So those of you who know what JSON is or BSON is, if you would have used a MongoDB or any non-relation database, so you know what key value pairs are. It's object in JavaScript where there is a key and there are values. So in a similar fashion, the KV store works. So you have a key and value, and that KV store saves all the data. So every transactions that gets added on the blockchain and whatever event that you do in the blockchain gets added to the KV store, which is a sub layer of the multi-store. So right now, what is important for you is to understand that multi-store saves your data as of now. Base app handles the transactions part and everything. Now, modules are very important. And if you would be building stuff using Golang, then you'll be creating modules for your own product or project, whatever you would be creating. Now, think of modules as a coupled units. So like, for example, I'm person one, and I'm trying to create a video streaming platform, and I create a video stream module. So every logic that my video streaming app needs, I'll be putting it there and then adding it to the Comdex SDK or Cosmos SDK. whichever feels, whichever explains you the thing. Both are same as of now. So I'll be adding all the video library, whatever I've created, video streaming project, and I'll be adding that as a module to the whole blockchain ecosystem. And similarly, if person B is trying to create an NFT platform, then he'll add an NFT module to the ecosystem. And that NFT module will have all the logic embedded to that particular blockchain for all the needs that he has. So for example, if person A wants to send an NFT and person B wants to sell his NFT. So all those logic would be written. So modules are self-sufficient capsule, think of code blocks that actually has all the logics. I'll be showing you a couple of modules that I have created, and of course, what Cosmos SDK has created natively. So these modules are or could be dependent on one another's, or they could be standalone modules. I'll show you examples of how they are. And each module has its functionality embedded for the blockchain, and they do their specific tasks. Problem statement is to create whatever functionality that your app needs, and the rest is already there, being made by Tendermint and Comet BFT, and that complete makes up a blockchain node. So what happens is, like I am a person who wants to create a very cool blockchain project through using Cosmos SDK. So what I'll do first is I'll take a fork of Cosmos SDK. I'll add whatever stuffs I want to add, and namely in the name of modules. And then what I'll do next is I'll get some people to validate. So what happens is that Comet BFT is a proof of stake based consensus algorithm. Tendermint is a proof of stake based consensus algorithm, which is different from what Ethereum or Bitcoins are. So they are proof of work mechanism. I'll be getting into details tomorrow of how the consensus algorithm works. But for a brief overview, what happens is that there are people called validators who validate everything that happens inside the blockchain. So just try to understand that validators are someone who try to validate everything, each and everything they validate what happens across the blockchain. And everything that happens inside the blockchain happens in the form of a transaction. So validators, in short, validate transactions. So now when I'm creating my blockchain, I'll have to have these people called validators on board my blockchain. So they'll be running this whole particular blockchain node. So this complete as a whole is a blockchain node. So I'll request them to help me and run blockchain node. Now they could run it anywhere. Very simple example would be running it on AWS, but then there's Akash as well. Akash is a blockchain platform that allows you to run nodes. So there are different places. Just think of running a server. So this blockchain node would be running on a server, and it would be running. It would be run by let's suppose I'm able to get 50 validators on my chain. So these 50 validators are running it for me, and of course I'll also run a validator just to be sure how things work, and just to have a seamless experience of how everyone is having. Now, these are the 50 places that my blockchain is running, and people would come do a transaction. These validators would validate it, and then the transactions would get added to the blockchain. I'll get into the architecture as well, how blockchain data gets, how transaction gets added to a blockchain. But state machine is what, as a person or as a developer, I have to be concerned with when I'm trying to build my own blockchain. And of course, with smart contracts, there is an issue where you just don't get to have a control over everything. So what I'm trying to say is, right now, state machine is built using Cosmos SDK because Cosmos SDK is a very mature engine. But you have a chance to run your own engine if you want to develop your own engine. Similarly, Cosmos SDK has its own SDK. Comdex SDK is a different version of Cosmos SDK, which has its own module. So it's like something that we are building and developing. Similarly, if, for example, person A wants to have its own implementation of Cosmos SDK, then he could have it and run as a state machine. Also, the consensus and the networking could be different. Comet BFT right now is a very mature mechanism, but in future, if there is a different one, they could use a different version. So let's suppose XYZ BFT is a new consensus algorithm, they could use it. But with smart contracts, you don't have that amount of freedom. You just have to build it on Ethereum virtual machine. And then whatever happens in your protocol, and if there is a change, like Ethereum had a upgrade last year. So as a app developer, so for example, let's suppose I was running a Uniswap. Uniswap was my app, and I was a developer who launched Uniswap on top of Ethereum. Just let's suppose this was a scenario. So when Ethereum guys decided to upgrade it, me as a Uniswap owner or a developer, I had no say in what Ethereum wanted to do. So as a blockchain owner, we have full say of Cosmos as a Cosmos SDK developer. We have full say of what is going to happen in our own ecosystem in our own blockchain. This is one thing that's great. Now let's get into the blockchain architecture first. So this is what the state machine is. So like deterministic state machine, this is example of deterministic state machine. For any given state at any given input, the end result or the output would always be the same for that particular given input. So this is what state machine is, and this is what they try to explain what when they are saying transactions, how they get replicated on a deterministic state machine. So this was what we discussed. Also, now this is one of the important stuff. So application is what we are building as Cosmos SDK, and then Comet BFT is the consensus engine. So whenever a transaction comes in, so for example, Rohit, I'm trying to do a transaction on the blockchain. So I'll send a transaction to the blockchain. It will get first added to this particular consensus engine, Comet BFT, and then ABCI, application blockchain interface. Through it, it will get to the application, my application that I just ran, and it will first be checked whether this particular transaction, there would be one level of check at the base level itself at Comet BFT. Then for stateful check, it would get to the application. All kind of checks will happen there. We'll get into the details as well. We'll be developing it. In fact, every check that gets happened in the blockchain level itself, we'll be developing it. We'll be writing it on our own, and I'll be showing you some of it today as well. So don't try to panic. So ABCI is very important. It's kind of a messenger between the Comet BFT or the consensus engine and the blockchain itself. So ABCI is very important, and there are different types of messages that ABCI does. One is check transaction. Check transaction is basically used to check when the transaction that has been sent by the user is correct or not. And after a lot of checks, it gets added to the mempool. I'm not getting into mempool right now because tomorrow I'll be going in depth of how Tendermint works, and we'll be getting into that as well. Also, like you guys have heard about mining, right? So blockchain mining was a big thing. Bitcoin mining was a big thing a few years back. So all those things, how it works in the Cosmos ecosystem, I'll be explaining it tomorrow as well. So that's all the consensus part. So I'm keeping it for tomorrow so that we don't get overwhelmed by all the information that I'm sending. Begin block and end block, I'll just give you a hint right now. It's very important. And think of a very simple example where you're creating a product. Just think of any product, not a blockchain product specifically. Think of a product where you're building something, and what has to happen is that every day at 3 a.m., you have to take a snapshot of your database. Let's just say this is something that has to happen at 3 a.m. through your code. Very simple example, snapshot of something, anything. So you run a logic, automatic logic that runs every day at 3 a.m. So those kind of logics that has to run on its own gets added inside a begin blocker or end blocker. So these are the automatic functions, like all those functions that we need to run automatically gets added in the begin block or the end block. So I just told you because I work a lot on these begin block and end block. So yeah, this is important. And I'll also be sharing you like how and what you have not, like how should you write your code and what are the things that you should avoid while writing a blockchain product or app. So this was mostly it on how like transactions get added to the blockchain. So first it gets with the Comet BFT, then through ABCI, it gets to the application level, it gets checked. And after all, it passes all the checks, it gets back to the Comet BFT. And then through different validators, it gets corrected, like, yes, it's correct. It gets passed. And then finally it gets added to the state through which it changes the state of the blockchain. And then it's get added to the blockchain itself. So this was mostly it. Now, these are the different modules that have been created by Cosmos SDK. And mind it, these are very important modules. It doesn't necessarily mean that you need to understand everything by heart, the code of it, all these modules. No, but you need to understand them on a high level, because while developing your own product, whatever you guys want to develop, you would be interacting a lot with the account module, bank module, staking module, and a lot other modules as well. So while I was telling you key person A sends some currency to person B, let's say INR is the native token of my blockchain. So what happens is this bank module would be very responsible for this particular transaction. So first of all, when I'll try to initiate a transaction from me to person B, bank module, I'll initiate a transaction first through any wallet. And when I initiate the transaction would first get added to Comet BFT. And as a part of the stateless check, it would check whether I'm trying to send a valid currency or not. So if I'll try to send -1 coins, it would just fail it. Then after that, through ABCI, when all the stateful checks would be happening, it will then go and check whether I have that amount of money or not in my blockchain account. If I don't have, it will fail the transaction. If I have, it will send the coins and then update the currency. So bank module is very important. And account module is again important because account is my address, which is there for a reason. And your seats are safe. And your seats are like your address and your seats are the very two important things that you need to understand, like how to interact with your own account. And there are different ways to secure your account. There are multi-sig accounts. So what multi-sig is, every time you sign a transaction from your account, like for example, you're initiating a transaction, you sign a transaction. That signing is kind of a confirmation that you give to pass. It's similar to how you write your password on your UPI app or your internet banking to initiate a transaction. So in a similar fashion, if multiple people want to be in control of a single account, then there are multi-sig accounts. It's similar to how joint account works in the banks. And then there's staking module. So staking is a very important part of proof of stake, and that's what Tendermint does mostly. So I'll be getting into more details, but yeah, staking modules is very important. And I think some of the products that gets built in this workshop, some of the projects that get built, will be using this staking module like on a very higher level. And it's very nice module. We have been using it, and everyone uses it. Like, every single project in the Cosmos ecosystem uses it. And then there's governance module, slashing module, minting module, distribution module. I'll just try to tell you what governance module is. So one of the major benefits of how proof of stake mechanism works is that it gives a control to the holders as well. So the native token holder will get a say on how things work. Depending, that also depends on how the project is running. If they don't have any governance, then it means nothing. So governance module allows you to vote on anything that proposals get added in the ecosystem. For example, let's think of Comdex SDK. I want to create a new product, and I want to take a grant of like $20K. So I'll write up a proposal, and if the proposal gets passed, I'll be getting that amount of money from the project. So it's a very base level implementation of how governance works. But there are more in-depth applications of governance, where, for example, we have written a mechanism where if you want to add an asset in the Comdex ecosystem, then it would first need to pass through governance mechanism automatically, and when it gets passed, it gets added to the blockchain ecosystem. So governance has a very important role. And at Comdex, we have two different levels of governance. One is a governance that has the similar governance as Cosmos SDK. That's the base layer governance. And then we have Harbor level governance that is on our Harbor app. You must have heard of Harbor app in yesterday's session. So these two level of governance are that we have right now. Slashing, minting, and distribution are not very important right now. So I'll be skipping those because it would get a bit more in depth right now, and I don't think we are ready for that. Yeah, and about the store. So I told you about the KV store, right? So at sub level, KV store exists inside the multi store. So the multi store is a overall store that you have. Yeah. So store is important to save your data, and it's responsible for your data, and everything that gets stored inside the store is in the form of key value pairs. So we normally call it KV stores, key value stores. You must be able to see that. And while you'll be building your own product, KV store would be a very important part of it. And you'll be storing data. And I'll get into these details once I start coding as well, because just reading them now won't explain you everything, because I want to show you some of the code that we write. So I'll be skipping this part, but yeah, multi-store is a high level store. And then like think of Venn diagrams. Multi-store is the outer level Venn diagram. And then you have inner small Venn diagram, which is the KV store. Each module has its own KV store. Then they get added and then become a multi-store. So multi-store is just a high level store that you see. But then every module, like we see here modules, right? Each module has its own KV store. When these all gets added, they become multi-store. Gas, yeah, transaction life cycle is important. So let me just say you explain you this. I have said this a couple of times in today's session, but let me say you this again. So at a very base level, you add your transactions, and like through your wallet, you initiate a transaction. User initiates a transaction through a wallet. That transaction, when it gets broadcasted, it gets added to the mempool, and then some base layer checks are done. And then after the checks are done through ABCI, it's sent to the blockchain for more checks, stateful checks. And after that, all those checks are done. It finally gets added to the block through validators. So validators, like first of all the validators would reach it. And when one of the validators would propose, now these two here are a part of the consensus mechanism. The third point and the fourth point are part of the consensus mechanism. So I'll be getting more into details. But think of at a very high level, you initiate a transaction from your wallet. Transaction gets added to the blockchain, but in the inside, like in the middle, what happens at that, it first get added to the mempool. Then a lot of checks are done. All the validators check it. One of the validators will propose this transaction should get added. And after all the checks are done at stateless level and stateful level, then finally the transaction gets added to the blockchain, and the state gets changed from A to B, depending on whatever was inside the transaction, and that gets added to the blockchain. So that's how transaction lifecycle works. Tomorrow I'll be going through a Tendermint, and then we'll be revisiting this topic again to explain you exactly how it goes. Gas and fees is like, think of fees is very simple, like fees everyone understands. So in Cosmos SDK level, you pay fees in the form of gas, which gets paid in the form of the token that you're trying to send, which is the native token of the blockchain. Right now, Cosmos SDK has an implementation where you could send fees in any token that you have on the blockchain. It doesn't need to be a native token. So things like these get added. Fee computation is something that I'll explain tomorrow. It's not a starter level thing, but I was taught this at a very starting level when I started in the blockchain ecosystem. So I'll explain you this, how it gets calculated. So stay tuned in tomorrow's workshop as well. And then these are some things that we don't need to understand right now. I just added them so that we'll go through these when we are trying to build the product. So these are important when you're actually building the modules, and then you're trying to connect it to your front end. So gRPC, REST, and Comet BFT endpoints, everything we'll be covering these when we just start creating the code. So don't worry about this. I just added them because you need to have an understanding of all these things that you have in this particular slide. I'll skip this. gRPC is like one level above REST, and then there's GraphQL as well. I think you guys mustn't have heard about GraphQL. If not, or if you have, then that's good. But if not, I would suggest you to go through GraphQL. It's a very cool thing. I have been learning it myself for quite some time now, and trying to use it in a product that I'm building, in a project, my own small project that I'm building. So now use cases. So use cases part is very simple, because those who are in this section must know something about Cosmos SDK and something about the products that Comdex has already built. So using the whole blockchain narrative and blockchain that Cosmos SDK provides, you could build your own gaming platform. You could build your own bank, for example, a lending and borrowing mechanism. You could also build your own stable coin. the way we have built our own CMST. So there are a lot of things. You could build your own decks. So a lot of things could be built. Supply chain has a very good scope for blockchain. I'm not sure if it's completely feasible, but yeah, supply chain has a very good option to be built. And gaming is something that I personally feel has a lot of scope in Cosmos SDK because gaming is yet to be explored. Every product, like when built on Cosmos SDK, will need to have a USP. And right now, all the products that are actually doing good have some certain USP, and gaming is not really there in those narratives. So I feel that gaming is something that we should focus on more building. In fact, in this particular hackathon as well, we have tried to leverage gaming. So gaming is something that you guys should focus on building, and we are there to help. I am personally there to help everyone who's trying to build something using Golang as well. So these are some of the notable projects and partnership. I don't think this is necessary right now, but yeah, there are a lot of partnerships going on inside the Cosmos ecosystem. We as a product have partnerships with a lot of different blockchains as well. So yeah, this was mostly the conclusion. I'll be getting into some of the slides that I've not done today, tomorrow, after explaining you Tendermint. So as a Golang developer, since I'll be taking part in the Go workshops more, so as a Golang developer, I would suggest you those who are trying to build the product on go inside this particular Comdex proto, again Comdex folder, and try to see what are written in these. So let's just go inside one of them. Let's go inside Vault. This is one of the modules that I have written. Very nice module. We should check it out. So there are different things. There is one called transaction, query, Vault, Genesis, events. So don't worry about Genesis and event. Go into transaction, query, and then Vault. So whatever functionalities that I needed inside my product, I added that inside a vault.proto file because Vault is the main functionality that I needed in my product. So I added all the functionalities there itself. All these are messages. These are similar, like if you have some coding experience, you would understand these are some of the format. It's roughly similar to JSON, not completely similar, but roughly you'll be able to understand there's this ID, and then we're trying to save some of the values here. So proto and at a high level is a structure of how your code base or how your data would get saved inside the KV store. So these are the different fields that we needed. ID, app ID. One of the things to note here is that the first parameter, or any parameter according to you, but in my case, I use the first parameter as the key of this particular value. So I saved it here as well for future purposes. Similarly, in this particular proto, I added app ID as the key and then added as a value as well. And these all are values. So we added this. Just try to go through this, try to make sense of what this means. And then you could go to transaction and query. Now, transaction here is important because this at some level is going to interact with you, or like if you're trying to interact with the product, then like, for example, if you create a product on Condex and that's in Go, then you'll add something in a transaction. And this is where the user will interact with your particular product. So this is what will create a mechanism. So message create request is what will come from the user. So these all data will come from the user. And as a response, like right now it's an empty response, but it depends because in transactions, we don't give a response back to the user. But let me show you this query. Query is trying to query a data of the state. So for example, transaction is when you're trying to do some changes in the state. Query is just trying to get a current state or some current data. So for example, see this query vault request. So user is sending some data. He wants something, so he's sending some data. And as a part of the response, we are sending him some data. Now the data is in terms of vault. So I'm sending him the vault data, sending them the vault data. So since it was a query, we had something in the response, but it was in transactions, we don't have a response mostly because user is trying to do something. He is not trying to understand something. So this is what the proto is. So I would suggest you go through this proto file, and then tomorrow I'll try to explain you what X means, and then we'll get into the coding.